Alrighty, again, a little unusual timing, but let's see if I can do this quickly. Valid triangle number, medium, given an integer array nums, return the number of triplets chosen from the array that can make triangles. Then we take them as side lengths of a triangle. So that means generally that the sum of the smaller two sides has to be less than or equal to the largest side, or I guess strictly less than. So 2, 2, 3 could be 1, 2, 2, 4 doesn't work because 2 plus 2 is going to be 4, so it'd be like a flat line rather than a triangle. 2, 3, 4 would work. I guess maybe this 2, this 3, and that could work. And that's it, right? 3? Okay. Okay, sure. So this looks pretty simple, I think. So first thing is, since the numbers are not sorted, it's going to be quite useful to sort. So 2, 2. I guess the main thing is how to do this without doing n squared, maybe n squared time wise. So right now, if you go for every smallest value, so outside loop is the smallest value in your set of 3, inside loop is your second smallest value. You'd probably do a binary search for where you'd find the longest side. So this is going to be n squared log n speed. N squared log n, 1,000 squared is a million log n. It's kind of slow. Okay, let's do kind of maybe simplest approach. This would be O of n squared log n. Outside loop, if A, B, C are side lengths of triangle, where A is less than or equal to B is less than or equal to C. Outside loop are iterate over A's. Inside loop, iterate over B's and find where C is using binary search. Okay, so let's say n is the number of values for every, let's say, A index in range of n, for every B index in range of A plus 1 to n. So let's say A is equal to nums at A index, B equals nums at B index, and we use bisect left. Okay, so let's say it's 2, 2. We'd have to search for 4, and whenever we find 4, whatever values come before that is going to be less than 4. Or maybe I can do bisect right for 3. Yeah, I'll just use bisect left, not inclusive of the value of the index. So C index is going to be where bisect left for this nums array. Probably use a hint here and say that you search for everything after B index. And, no. So the array is the first parameter, second parameter is the value that you're searching for, which is going to be A plus B. And the next parameter is like the left bound index that you're searching through, which is by default 0, but here it's going to be after B index plus 1, after B index. I think that's fine. So this is not inclusive. Is that right? Yeah, not inclusive of the C index. I guess I can do this thing minus 1. Yeah, that's fine. And then the answer is incremented by the number of values between B index and C index. Okay, I think this might work. Let's see if I need to optimize. Ah, shucks. Okay. Interesting, it didn't work. Okay. Let's go ahead. Print out the answer each loop. So let's go and print out the nums array after the sort. Okay, so it's 2, 2, 3, 4. After the first loop, the answer is 1. It's 2, 3, 4. That's right. Now the answer should be 2, because it should be... No, the answer should be 1. There should be 2, 2, 3. Two, two, three, two. No, the answer should be 2. It should be 2, 2, 3, and 2, 3, 4. So, what is going on here? B index. So when it searches for A is 2, B is 2, wonder if this is plus 1 or if it should just be B index. Let's see if that makes a difference. I don't think that should be the difference. Yeah. A and B. A plus B is the value that you're searching for. Should be the upper bound. Okay, I guess I just need more printouts here. Print A, B, C index minus B index. Okay, so this is the sorted version 241. It's actually not what I expected. I expected 2, 2. Why is B4? Index is 0, the index is 1, nums at 1 should be 2. I'm doing something pretty bad here, I think. I'm missing something pretty obvious. This should print it after the actual assignment B. 0, 2. Oh, wow, that's really bad. A index rather than A. Okay. Okay, I think this might work. Nope. Oh boy. Okay. A index plus 1 to n. B index. Alright, let's go ahead and go put that back in. 2, 2, 2. That's correct. And then 2, 3, 1 is, this should be 2, 3, 2, 2, 2. 2, 3 should be 1 here. There's one thing that works for the triplet that starts with 2 for A, 3 for B. So why didn't that work? So C index is bisect left. A plus B should be 5. B index plus 1 should be 0, 1, 2. Should be 3. I wonder. Huh. Searching for 5. Should be returning the index that is like 0, 1, 2, 3. Okay, I guess I just need to print out this thing. No. Maybe it's just off by 1. So you include, so 0 is A index, 1 is B index. It should find 4. 2, 2. Actually, yeah, this should be 1. So I think it's off by 1. Okay, maybe I should just use -1 here. And I guess make this now. Okay, see how fast this goes relative to other answers. Okay, pretty slow. 1290. Huh, interesting. I guess it's doing a search each time. Hmm. 1290 is pretty slow. Solutions generally are going to be 400 milliseconds. I guess searching each time is probably pretty slow. Searching for the sum value. So searching for the sum value. Huh. If I did two, can I do like a two-pointer technique here? One pointer for do 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 do. Hmm. What if I just did n squared technique? So if I is 1,000 length. Values are up to 1,000. The values are up to 1,000. Let's think about that. If I sort it, and then put an array where it does a count of all the values in the array that are that or smaller, or maybe that or bigger. All the values in the array that are that or smaller, almost like a prefix array, but not really. Then I could avoid the search, so I can just go directly into the array at the count of the sum subtracted by the count of the larger of the smaller sides. Oh boy. Chosen when they make triangles if you make them as side lengths. Yeah, so this is n squared log n. Could make it just n squared. That doesn't seem that fast. The difference between this and n squared, I don't know if this is log n factor. Okay, let's just try. And let's say the max value is max of, actually, it's just going to be the last value in nums at this point. So counts is going to be 0 times the max value plus 1. And how would I go about getting count here? So let's say index is at 0 for every value in your sorted nums array. So let's say it's 2. Actually, I think it's for every k in range of max value plus 1, while nums at index less than or equal to k, count plus equals 1, index plus equals 1. At that point, maybe index is the same thing as count. So this counts. So if it's 0, then there's 0. If there's 2, then it goes up to 0, 1, 2. Okay. And then you do the count, and then you store into counts at k, whatever the current index is. While nums at index less than or equal to k. If k is okay. This goes out of bounds the last time. I think maybe I can just add. Let's just add a blocker here. Well, index is less than or equal to length of nums. Okay, so max value here is 4. So this is like 0, 1, 2, 3, 4. So the number of values that are less than 0 is 0, less than 1 is 0, less than 2 is 2, less than 3 is 3, less than 4 is 4. Again, max value is 4, so 0, 1, 2, 3, 4. Number of values less than 0 is 0, less than 1 is 0, less than 2 is 1, less than 3 is 2, less than 4 equal to 4 is 4. Okay, that's what I wanted. So rather than doing a bisect left to determine this, it's answer is going to increment by the number of values counts at a plus b minus 1 minus what exactly? Minus b index, or b index minus 1. So either b index or b index minus 1, I think. Not correct at all. Index out of range. I see. It's because a plus b is going to be possibly bigger than the max value. Okay, I think I just extend this out to the highest possible max value, which was I think 2000, maybe 2001, something like that. A in range of max value. Okay, I think that's probably fine. Oh boy. Okay, let's think about this. K represents the largest value. A plus B. A plus B. Yeah, counts should actually be initialized in this case to be the number of values in the array. Because it can't just be zeros at the very end of this counts. Okay, yeah, it's off by 1 again. So this is strictly n squared. Well, it's not anything squared. 0, 0, 0. Interesting. Just give me in terms of counts. 3, 3, 3, 3. Okay. It's just this something that is a special case, or is this going to be wrong for other cases? Let's try 0, 0, 1. 0, 0, 1 is also incorrect. Turns to -1. I think I just need to skip special things that are 0. It just doesn't work. If a equals 0, continue. that just can't be assigned. Okay. Interesting. Interesting. So I don't really know how to interpret this. Like, are there faster solutions? Maybe. Guess I don't need max value. Counts. Maybe I can use max value. Maybe I can use the biggest count that I really care about is maybe twice the max value. So length of nums times max value times 2, something like that. That's slightly faster. Doesn't work. Maybe max value times 2 plus 1. Because there's 2001 before, right? Okay, doesn't really make much difference. Oh, there's this thing too. I could probably get rid of this, like while index. So it goes out of bounds. It goes out of bounds at the end here, and if I just make a dummy value at the end of the nums array, I think it stops going out of bounds. So I get rid of this. Nums index is less than or equal to k. So if I make a dummy nums ending here, nums append infinity, that should also stop the loop from going past that point. Yeah, this just doesn't change. Okay, I guess this is as far as it goes. Summary. So first approach, let's say assume A, B, C are triplets or side lengths of valid triangle in order, in increasing order. First approach is use nested loop to determine count of valid triplets. Outer loop iterates over possible A. Inner loop iterates. Oh, okay. So fairly obviously start by sorting the nums array as that's what the hell's going on here. So that's pretty useful to structure the values. First approach, use nested loop to determine count valid. Outer loop iterates over possible A's, inner loop iterates over possible B's, and inside inner loop find where C, which is approximately A plus B, is in the array using binary search, which is like the bisect left, and determine the number of valid triplets based on like the C index minus the B index. This is again ignoring the finer details of inclusive, exclusive, of those values to determine exact count. And technically, I think the way I did it, I need to do a -1 on that. So yeah, this is the outer loop, this is the inner loop, and then there was a bisect left in the inner loop. Unfortunately, that was too slow. Basically, searching for the C index is log n of log n. Given the constraints and defined maximum values for A, B, C, is less than or equal to 1000, can basically hard code the counts, or can basically pre-compute the counts of values that are below a certain value, and use that to determine the counts of values between or within a certain range, i.e. If want to find the number of values in range between B and C, then that would be the count of the number of values at C minus the count of the number of values at B. Count of the number of values within the array that's less than or equal to C minus count of the number of values within the array that's less than or equal to B. So that's the second approach. Pre-compute the count array. So that's this thing here. Counts array, you can assume that whatever your max is, all your values are going to be less than or equal to your max, so that's your initial value. Initially it's going to be 0. Iterate through the possible values, count the number of values in the array that's less than or equal to that, increment the index, and then the number of values less than or equal to that, and your counts array is equal to whatever index you are at within your nums array. Then use that to quickly determine how many values fall between B and C in the inner loop above. All right, time complexity, this is going to be O of n squared as the outer and inner loop iterates over n. The work inside the inner loop is constant, which is subtracting two values, or subtracting values from the counts array. The work to create the counts array is O of n, as it iterates over every value of the nums array. Note here, this is kind of a two-pointer deal, but because the index pointer never exceeds the k pointer, the number of times the k pointer increments is at most the number of times the index pointer increments, so it's going to be just n times overall. Space complexity, this is going to be O of n, or O of a max of n, since the counts array has size equal to or proportional to the max value within nums array. Like if the nums array was 2000 in size, then technically it'd be like 4000 is the maximum possible